Hi everyone and welcome to Chem class. Today I'm going to talk to you about solubility curves, and for the sake of my example, I've just put together a solubility curve with substance X and Y, so just two hypothetical substances showing their particular solubility curves. Let's unpack what this first means before we look at a couple of questions. First of all, we understand that some ionic compounds are soluble and some are insoluble and some are even slightly soluble. So, the first thing we need to understand is when something is soluble, it means that it can dissolve in water and it will make a lovely solution where you can't actually see that ionic compound anymore because it's nicely surrounded by the water. However, no two ionic compounds really have exactly the same solubility curves, and that's because although they can dissolve in water, there's a certain amount that will dissolve in that water. You can't dump, for example, one whole cup of sugar into a teaspoon's amount of water and expect all of that cup of sugar to dissolve in that amount of water. You know that there's just not enough. So there's obviously an amount that the water can dissolve, and it's also going to be dependent on the amount of water. Not only that, we also know that if we were trying to dissolve a cup of sugar into some water, well, if we were making a hot cup of tea, it's a lot easier than in a cold cup of tea because the temperature of the water will make a difference to solubility. Ionic compounds, or any solid really, has a trend that as the temperature increases of the water, more of that solid will be able to dissolve. So you can see in my two hypotheticals that the curve goes upwards. As the temperature increases, so does the solubility. These curves, though, are always presented in a certain way. The solubility, as it's listed on the axes, is of how many grams of that solid will be able to dissolve in 100 grams of water. We have to keep some variable constant because we want to just look at the difference in solubility, not the amount of water. So we change the temperature as well to see how in that same amount of water we can change what the amount of that particular solid is going to be dissolving. So let's compare now X and Y. So what I've got is both of them, first of all, will be able to dissolve a certain amount of water at very low temperatures, but as the temperature increases, so does their solubility. But we see that X is actually a much more soluble substance than Y is. We still consider them both soluble, but we can actually dissolve more of X in the same body of water at different temperatures than we can of Y. So that's how those two compare. When you look at solubility curves of a variety of solid substances, you'd see that the curves are all sort of slightly different. Okay, so how do we answer questions? The key bit is that this axis is per, as I said, 100 grams of water. So let's go over to my first example of a question. Kept that one nice and simple. How much of substance X, so we're following the blue curve, can dissolve in 100 grams of water? So we're reading the data exactly off this curve as it is. We don't need to do anything to it. At 40 degrees. So I look at 40 degrees. I track that point up all the way until I hit my blue line because we are asking about substance X. I follow it along and I see that would be between 60 and 80. So let me draw that, mark that on there so that you can easily see that. So 40 degrees, go along. There we go. 70 grams of substance X will dissolve in 100 grams of water. They've only asked about the 100 grams of water, so my answer is going to be the 70 grams. We can read it straight off that. Let's see how my second example differs. How much of substance Y, so we're following the green curve now, can dissolve in 300 grams of water at 30 degrees? So the thing is that because this curve is only represented as per 100 grams of water, we have to pay attention to that 300 grams. We need to get our data from this curve and then we need to multiply it up because we're asked about 300 grams of water. So at 30 degrees, I'm going to go to my 30 degrees, track it up to my green curve, go across, and that would be, and I'm going to write this down, 15 grams in 100 grams of water because That's the data I'm getting off here. It's per 100 grams of water. The question wants per 300 grams of water. Now, some of you might clearly see what you need to do with the 15. You need to multiply it by 3. But I'm just going to sketch this out. If I had 100 grams of water, let's pretend this is a cup with 100 grams of water in it, I can only dissolve 15 grams. That's as much as is going to dissolve in this particular cup, okay? 15 grams of substance X. So substance X is green. 1, 2, 3, 4, 5. That's my 15 grams. If I have 3 lots of that, we multiply that, another 15 grams, another 15 grams. So essentially it is the 15 grams times 3, which equals 45 grams is my answer. This question could have also been a different number, could have been 500 grams. I would times it by 5. I'd times the amount that went in the 100 grams by 5. And also, it could have been a smaller amount. So instead of being per 100 grams, it could have been asking about 50 grams of water, in which case we know that what we have is only half of that 100 grams of water. So whatever we could dissolve in the 100 grams, we would need to halve. So it just becomes a factor of the 100 grams. Do I need to divide it by a number or multiply by a number just to get to the amount of water that it is asking about? Hope that helps.